The next question is, what is the maximum height of the projectile? Now I'm going to assume you have the time up, the initial velocity, final velocity, and the components. So which equation works? And the answer is all of them. We have so much information, any of the distance ones will work. For example, distance is equal to the initial velocity plus the final over 2, that's the average velocity, times time. Now, do you realize we have everything? Let's plug in what we know. The final velocity on top is 0, and therefore the initial velocity, d, is equal to, well, we threw it up with, remember, 10 meters per second, divide by 2. The time upwards, because we're only going to the maximum height, will be 1.02 seconds. Easy to calculate. This may be the best one to use. And we find the answer, it's distance, but it's actually the height. How high did this go? And the answer is 5.1 meters when we round it off. Let's try another equation so you can see what I mean. Like, you have many choices of how you want to proceed. Let's try this one here. Vf squared is equal to Vi squared plus 2ID. Now, 2AD. Now, you have to make sure that you arrange this properly and get your minuses right. But the final velocity on top was 0. Therefore, when I bring the Vi squared, it's negative Vi squared equals 2AD. And A is G, and I want to solve for D, so D becomes negative Vi squared, that's on top, which was negative 10 squared, divided by 2 times negative 9.8. Remember the negative. And it's negative of the 10 squared. So I'm going to end up with a positive number, and it becomes 5.1 meters again, just like the other one. Now, I won't work the other one through all the way with you, but you should try it just to confirm this. But D is equal to VIT plus 1/2 AT squared. And you have all the variables you need. A VI, remember, is 10. The time up, 1.02. The half you have, and A is negative. Don't forget to put negative in, 9.8, and then square the T. And again, you plug that through and you'll find that the distance is 5.1 meters. That's the maximum height. Our next question is, what is the range of the projectile? And now we looked at how to find the range. We used the horizontal component this time. And so we know the horizontal component, and the range is equal to the distance in the x direction, d sub x, which equals the velocity in the x direction, the horizontal component, times the total time in the air. And so these are easy to calculate. The sideways velocity, if you recall, was 17.3 meters per second, and the total time in the air was 2.04 seconds. Again, very simple to calculate the range, and this is how we do it. And our final answer, you put it through your calculator, notice the seconds cancel. I get 35.3 meters. Make sure you rework these on your own.